Okay, so this is 7.1 part 2. I'm just finishing these last three problems. So for these last three problems, I'm going to do both parts of the instruction. So first, I'm going to find any number that would make the expression undefined. And then two, I'm going to simplify the rational expression. So you should have watched part 1 already, which explains how to determine which values make the expression undefined. So to do that, you are supposed to set the denominator equal to 0, because essentially what we're doing is we're trying to identify any numbers that would create a 0 in the denominator. So x squared minus 6x plus 9, this is number 7. We're trying to solve for x. So we're trying to identify values of x that would create a 0 in the denominator. So it's already equal to 0, so I'm going to factor. So factors of 9. So x cannot equal 3. So 3 is the value that would make it undefined. And then we are going to simplify, which is part 2. So simplifying says you factor where you can. So my numerator is x minus 3. I can't factor that anymore. My denominator is x minus 3 times x minus 3. So when I simplify that, my x minus 3's cancel. Remember, when everything is gone at the top, there's always a 1 because everything is times a 1. So 1 over x minus 3. And that would be it. So this looks terrible. So x cannot equal 3, and then the simplified answer is 1 over x minus 3. Okay? All right, let's look at another one. So number 8 for part 1, we would take the denominator, 4x minus 8, and equal it to 0. So x is equal to 2. So I set it equal to 0, and then I solve for x. I don't have to factor here. It's an x with an exponent value of 1. So I just solve like I learned in chapter 2. Just isolate the x. So I get x is equal to 2. So that's the value that would make it undefined. And then I'm going to take my problem, 2x squared minus 8 over 4x minus 8. And I'm going to do part 2, which is to simplify the rational expression. So remember, the rules for simplifying say to factor and then cancel like factors if possible. Well, factor if possible, then cancel like factors. So my numerator, you should take your top and your bottom and factor them separate from your problem. So GCF, x squared minus 4 is the difference of two squares. So my numerator factors into 2 times x minus 2 and x plus 2. And then my denominator would factor into 4 times x minus 2 because there's a greatest common factor. So when I look at my factored answers, I see x minus 2 and x minus 2 can cancel. So I'm left with 2 times x plus 2 over 4. So now 2 and 4, 2 is a factor because it's multiplying to an x plus 2. So 2 and 4 can reduce. So we get x plus 2 over 2. Final answer. If you want to write the 1, you can write the 1. That's fine. And so that would be it. Remember, the 2's cannot cancel each other out here because that's x plus 2 is the factor. All right, so it's very important to pay attention to that. Okay? All right. And then the last one, number 9. So we set the denominator equal to 0 when we solve. So x is equal to 4, right? So I added 16 to both sides first, and then I divided by 4. So if x is equal to 4, that's what would make it undefined. So x can never equal 4. And then I take my problem, 3x minus 9 over 4x minus 16. I'm going to factor where possible. So there's a GCF there. For my denominator is a GCF. So I get 3 times x minus 3 over 4 times x minus 4. So when I factor to see if anything can cancel, There are no like factors. So this just means that this rational expression or this fraction was already as simplified as it could get. But I wouldn't have known that if I didn't factor it. So when I factor it and see that nothing can cancel, that is just my final answer. So you should leave your answer in its factored format. Okay? And that's simplifying rational expressions and identifying values that make it undefined. So that's your 7.1. It's all about factoring. Factor where possible, cancel out like factors. And that's that.